Thank you for outlining the NC State SMIC's value proposition for SESMII members. Next, we'll hear from Craig Dory, the director of the SMIC at Rensselaer Polytechnical Institute.
Hello, everyone, and welcome to SESMII Smart Manufacturing Summit. My name is Craig Dory, and I am director of SESMII's Smart Manufacturing Innovation Center at Rensselaer Polytechnic Institute in Troy, New York. I'm looking forward to introducing our SMIC to you today. RPI is a top research and engineering school with core smart manufacturing-related competencies in modeling and control for discrete and process manufacturing, as well as artificial intelligence and machine learning. We leverage those strengths and our one-of-a-kind Manufacturing Innovation Learning Lab, or MIL for short, in our SMIC. The MIL at RPI is an agile, advanced manufacturing research and learning lab whose makeup mimics real-world environments of many small to medium manufacturers and serves as a real-world platform to help educate the next generation of manufacturing innovators. The MIL has a broad range of manufacturing systems, from modern CNC turning systems, 3D printers, and 6-axis robots, to legacy ultrasound welders, lathes, and plastic injection molders. The RPI SMIC creates a unique environment for manufacturers to experience smart manufacturing in action. Our focus is on industry engagement, education, and training, meeting small to medium manufacturers where they are, with a familiar manufacturing environment to help them take their first and next steps on their smart manufacturing journeys. RPI is all in on smart manufacturing, making a significant portion of its manufacturing-related facilities and equipment available to the SMIC, including the MIL. By the end of this year, more than 25 of our discrete and process manufacturing systems are slated to be integrated with the SESMII Smart Manufacturing Innovation Platform, or SMIP. Nearly 50% of those systems are legacy systems with no digital control. So we are able to demonstrate real-world manufacturing environments that mirror those of many small to medium manufacturers and highlight solutions to a key challenge they often face: how to automatically gather and contextualize operational process manufacturing data from legacy equipment. In addition to RPI administration support, students and faculty at RPI are well aware that smart manufacturing is key to manufacturing primacy and resiliency in the United States. This is evidenced by outstanding student and faculty participation in smart manufacturing-related classes and SESMII-funded projects. The RPI SMIC is very fortunate to be partnering with Smart Manufacturing Systems Integrator, Toward Zero, on the work to integrate our diverse collection of manufacturing equipment and systems with the SESMII SMIP. In a strategic partnership with the RPI SMIC team, Toward Zero has developed the functional requirements and designed the connection strategies for RPI's manufacturing equipment with the SESMII SMIP. Toward Zero is developing a smart manufacturing edge device called Apogee, so manufacturers can quickly and inexpensively capture data from legacy equipment and eliminate protocol barriers in manufacturing IT/OT architectures. We are deploying several prototype Apogee devices here at RPI to provide controllable interfaces and protocol conversions from our manufacturing systems, including legacy systems, to the SESMII SMIP. Beyond is working with Toward Zero to install their new EdgeX Connect OPCUA server at RPI to begin tackling the challenge of instantiating a common information model for the RPI SMIC. Machine Document is providing a unique solution for easy retrieval of key system data, including operating manuals, schematics, and connection strategies for each of our connected manufacturing systems. Haas Automation and Sandvik Coromant are key longtime MIL strategic partners. Other than networking services performed by the RPI.CIO staff, all the systems integration work performed to date for the RPI SMIC by Toward Zero, Beyond, and others has been performed remotely due to the COVID-19 pandemic and resulting RPI campus visitation restrictions. It wasn't designed from the beginning as such, but this has become an excellent example of how smart manufacturing implementations can be low cost and have a small operational footprint. As an example of one of our integrations, this is a diagram from Toward Zero's design document for the RPI SMIC. It outlines a connection strategy for our Haas ST10Y Y-axis turning center. From bottom to top, the first layer illustrates a physical connection from our ST10Y to the Apogee through the RPI network to the internet and RPI instance of the SESMII SMIP. The second and third layers illustrate the time series data flow and connection method between each device and network element, from the ST10Y via the Haas MDC protocol to the Apogean, where 24 attributes or tags from the Haas data stream are translated to OPCUA, and a GraphQL script ingests the time series data into the SMIP and establishes a machine profile mirroring Haas's flat data structure. This illustration shows selected live data from RPI's Haas ST10Y, charting trend lines for part count, spindle RPM, feed rate, tool number, and a few other attributes over a period of an hour. The trend lines show part count monotonically stepping as each part is completed, along with expected changes in the feed rate and spindle RPM time series as the various programmed cuts are performed. For this program, the state, mode, tool number, and execution active tags are all constant for this time window, as the program cuts a simple part and there were no tool or mode changes. Student teams in 2 RPI classes are currently developing 3 vertical applications to analyze manufacturing operations from the ST10Y, including an OEE, or overall equipment effectiveness calculation, to measure manufacturing productivity, a tool wear measurement app to predict tool wear from cutting operations, and an energy usage management analysis tool that can be illustrative by itself or be used in combination with other metrics and analytics. We expect to be able to reuse and expand upon these data analytics applications for other similar manufacturing systems as we begin to implement a common data model for the SMIC. RPI researchers have been fortunate to have been involved with and or lead several CESMII-funded enabling R&D and innovation projects, working with top manufacturers and solutions providers across multiple industries. These projects include incorporating smart manufacturing to optimize steel slab quality, improve energy efficiency of air separations units, optimize manufacturing of monoclonal antibodies, and improve productivity in apparel manufacturing. RPI researchers are also developing a Bayesian dropout approximation modeling engine with sophisticated predictive capabilities as a data analysis service that can be invoked by SMIP applications to model a variety of manufacturing processes. The RPI SMIC has long-term working relationships with economic development resource partners, including regional NIST manufacturing extension partnerships across New York, Connecticut, Massachusetts, and Southern Ohio that help manufacturers grow and thrive. We also work with community colleges across New York and Connecticut to encourage development of smart manufacturing curricula and training, and with New York's Workforce Development Institute to help fund training for new and embedded workforces. Additional manufacturing resources that we work with to build smart manufacturing capabilities include the Metal Casting Center at the University of Northern Iowa, CCAT in East Hartford, Connecticut, TechSolve in Cincinnati, Ohio, and GW Process Optimization located in New York's Mid-Hudson region. The CESMII SMIC has a broad range of next steps planned, including developing new operational analytics, predictive models, and optimizations to dramatically improve productivity and enable model predictive control. Developing and implementing low-cost turnkey smart manufacturing systems for small to medium manufacturers to reduce cost and risk, speed implementations, and drastically improve time to value. We also want to develop at least a dozen new industrial and strategic partnerships over the next year and expand into additional verticals. We plan to further develop the Smart Manufacturing Research and Education program at RPI and continue to work with CESMII to offer smart manufacturing assessments, helping manufacturers assess their readiness to start the smart manufacturing journey and develop insight to take the next steps. Calling all CESMII members, manufacturers and software hardware vendors alike are invited to kick the smart manufacturing tires in RPI's Innovation Sandbox. Manufacturers, you can develop and test solutions to your smart manufacturing challenges in our facilities to minimize implementation downtime in yours. Hardware builders and software developers, you can develop and beta test your smart manufacturing solutions in our real-world environment. The RPI SMIC offers access to smart manufacturing experienced students at both the undergraduate and graduate level, as well as to RPI faculty and staff with rich smart manufacturing domain experience to help define and execute your project. As well, we are happy to introduce you to our strategic industry partners and to economic and workforce development resources to leverage their experience. And stay tuned for the RPI-SMIC grand opening and workshops later this year or early next. Thank you. Please don't hesitate to contact me with any questions or for more information regarding the CESMII SMIC at RPI.